In this example problem, we're going to look at torques in an equilibrium condition. So what we have for this problem is we have this board. So the first thing I'm going to do is I'm just going to draw out the situation. So we have this board, and we know the board is 12 meters long, and we have these two different supports. So we have a support somewhere over here, we have a support somewhere over here. They're on each side of the center. We know that they're equidistant from the center of the board. So if I draw the center of the board, let me do that again. I know that this is going to be my center of mass, and I know that it's 6 meters from the center of mass to each side of the board. And I know that these supports are equidistant. I don't know how far they are. That's what we're trying to find. So I'm just going to label those as x. Now the whole point here is if we were to take a mass of 100 kilograms and place it somewhere over here, actually it's exactly 1 meter from the end of the board, we want to know where we could place our supports where we would be able to support that 100 kilogram mass. So if we look at our forces, we have a force from this support pressing up, I'll call that F1. We have a force from this support going up, I'll call that F2. We have a force of gravity caused by the center of mass of the board going down, I'll call that Fg1. And then we also have a force of gravity going downwards caused by that 100 kilogram mass that we have over on the end of the board. So I'll call that Fg2. So what happens here in the equilibrium situation is that we know three things. We know that the sum of our forces in the x direction equals 0. We know the sum of our forces in the y direction equals 0. And we know that the sum of our torques equals 0. So all three of those are true in this case. So what I'm going to do is I'm just going to go through and I'm going to try to fill in these equations, create these equations that we can use in order to solve what we're trying to find. Now, in the x direction we don't have any forces, so we don't have anything we need to fill in for that first equation. So the sum of the forces in the x direction equals 0 because there are none. So that makes sense. In the y direction, we have F1 that's going up, so that's positive. I'll say up is positive. We have Fg1 that's going down, so I'm going to say minus Fg1 plus F2 minus Fg2. So it's important to keep the direction in mind here, just like what we've done in the past. For the torques, now here's where things get a little more interesting. What's going to happen here is if we're looking at the point where this 100 kilogram mass is going to be placed at the end of the board. If we're trying to figure out how far these supports must be placed from the center in order to support that 100 kilogram mass, we're looking at the point where essentially the board could tip around this support. So our axis of rotation is going to be directly on that support over there on the right that's closest to the mass. So what we need to do is we need to look at our torques relative to this axis of rotation here on the right support. So if I were to do that, we know that F1 is a distance 2x away from the other support. So we have F1 times 2x, and that's going to cause a clockwise rotation. So that's going to be a negative torque because the board would go up. We have Fg1 over here, and Fg1 is a distance x away, so Fg1 times x, now we just need to figure out, is that going to be positive or negative? Well, it would cause a counterclockwise rotation, so that's a positive torque. And then we don't have anything with the second support over here because it's on the axis of rotation, so its distance is 0 away, so that won't apply. And then finally we have Fg2. So Fg2 is a distance away. Now, if we know that it's 5 meters from the center, because I know that it's 1 meter from the end of the board, so it's 5 meters from the center, and we know that the support is x away, this is going to be 5 minus x. from the support. And then we need to see what's going to happen here. This would cause the board to go downwards, so that's going to be a clockwise rotation, so that is negative as well. So these are the equations that we have set up. So if I look at the equations, for the first one, I have F1, I'll just simplify this, plus F2 equals FG1 plus FG2, which is fine. Then for the second one, if I just put all the negatives on the other side, so I'll have F1 times 2x plus FG2 times 5 minus x equals FG1 times x. What happens in this case, since we're looking specifically at where we're going to place this, where the axis of rotation is going to be on this support over here on the right, at the distance that this is going to be away, where we just support this 100 kilogram mass, this F1 is going to end up equaling 0. Because we're saying that at that moment, there's not any normal force that's being pushed up on the board. So if we go too far in, it's going to tip. It's going to rotate. So we're looking at this condition where this force is equal to 0. So F1 equals 0. So if I just replace that with 0, we end up basically with just F2 equals FG1 plus FG2. And then for the second equation, we have FG2 times 5 minus x equals FG1 times x. Well, here's the thing. We don't even need that first equation because we're trying to figure out what x is. So I can do everything just from this second equation. Since I know the mass of the board and I know the mass of the 100 kilogram mass, I can just plug in what I have for that second equation and solve for x. So if I do that, we have here just FG2 times 5 minus x equals FG1 times x. FG2 is just 100 kilograms times 9.8 meters per second squared times 5 minus x. FG1 is 5 kilograms, because that's the mass of the board, times 9.8 meters per second squared times x. So if I just want to solve this, I can just multiply out what I have. So 100 times 9.8, that's 980. 980 times 5 is 4,900. So I have 4,900. I'm not going to worry about the units just for the rest of this for now. Minus 980x equals 5 times 9.8 is 49. So 49x. So if I just solve this for x, so add 980x to both sides, so 980 plus 49, and then 4,900 divided by 1,029 is 4.76. So 4.762 if I go out to 3 decimal place. 4.762 meters. So what that means is each of these supports would be placed 4.762 meters from the middle in order to support that 100 kilogram mass. You can place them farther than that, and that'd be fine. But if you place them any less than that, it's going to cause a tipping situation where the board would tip if you place that 100 kilogram mass 1 meter from the end of the board. So this is what we're looking for our answer to this problem.